In today's video lecture, we're going to discuss about what is the deterministic finite automata. In short term, we call it as DFA. What is DFA? Is a deterministic finite automata. In that DFA, we're going to discuss what are the tuples, okay? Myself, Sharmila, assistant professor in CS department, RMD Engineering College. We're going to discuss about deterministic finite automata. That is deterministic finite automata. Before going into that, we're going to discuss what is sigma star and sigma plus. In the last video, we have discussed what is sigma star. What is sigma star? It includes epsilon and sigma 0, sigma 1, sigma 2, and the n. And then in the sigma plus, it includes sigma 1, sigma 2, sigma 3, not the sigma 0. Okay. What is regular language? It's a language exactly that have some description, some recognized finite automata. For example, in the computational model, we have to focus on what is finite automata, whether it is a good model, we can solve it extremely limited amount of memory is there, we can solve the problems, correct? In that finite automata, we have a tuples. There are 5 tuples in the finite automata. In the mission, we used to recognize the pattern within the input taken from some character. That alphabet is called as sigma. That finite automata may accept or reject that particular values. So that accept means it goes to accept state. If it goes to reject means it will go to reject state. In that finite automata, we have 5 tuples, that is Q, sigma, del, Q naught, F. Q is a finite set called the states. Sigma is a finite set called the alphabet. Del is a del transition function. Q naught is a start state, starts with the letter, maybe a capital letter Q, A, B, whatever it is, it starts with an arrow mark. For example, if you have a state, that is state is represented as circle, I'm giving the name for the state A. If it is my start state, I should include the arrow mark in the beginning of the state. That is a Q naught. It's a start state. F is a final state. Final state representation is using the double circle. Final state is used using a double circle. So I can give any alphabet. For example, I am giving B. Okay. It should be used as a double circled state. That is a final state indication. Okay. So there are 5 tuples. One is Q, sigma, del, Q naught, and F. So here we have one more definition for NFA, that is non-deterministic finite automata. The non-deterministic finite automata, it's have each input automata transferred to several states at once. But in the DFA, only one input, it goes to one state. But if you see that in NFA, for example, if you see this 0, it goes to Q1. If you give one input, it goes to Q2, but only one state. But in NFA, if you give 1, it goes to Q1. If you give 1, it goes to Q2. There is a 2 options for NFA, non-deterministic finite data. It goes to a several state at once. What is non-deterministic automata? It go to a several states at once. But in the DFA, only one input, it goes to the particular input state. One input goes to only one state. That is called as a deterministic finite automata. So finite automata have a mission. That mission have, for example, you have the Q1, Q2, Q3. There is a 3 states. They are given 0 means if Q1, it goes to Q1. If you give 1 means it goes to Q2. In Q2, if you give 1 means it goes to Q2. In 0 means it goes to Q3. If in Q3, if you give 0 means Q2. In Q3, if you give 1 means it goes to Q2. Okay. This is a given question. For this question, we're going to describe formally, we're going to write Q, sigma, del, Q1 and F. What is Q? There are set of states. What are the states here? Q1, Q2, Q3. What is sigma? Is a set of input symbol. What is the input symbol here? 0, 1. And del is nothing but transition from one state to next state where it moves. That comes under the transition. And what is Q1? It's a start state. What is Q1 here? It's a start state. It starts with the arrow mark. What is the final state? Q2. Q2 is the final state in double circled. correct? So here what we have discussed is what is about 5 states. That 5 states are Q1, Q2, Q3, correct? In that Q3, that is 5 tuples. 5 tuples are Q. Q is a Q1, Q2, Q3 number of states. Sigma is the input symbol 0, 1. Del is a transition from one state to another state where it moves. For example, if you are giving the two inputs 0 and 1, 0 and 1, if you give in the Q1 0 means it goes to Q1. If you give 1 means in the Q1 it goes to Q2. That is called as del transition. In the Q2 you see if you give 1 means it goes to Q2 itself. That is a self loop. It's called as self loop. The state goes to the same state is called as self loop. And then if you give 0 it goes to Q3. In Q3 if you give 0 it goes to Q2. In Q3 if you give 1 it goes to Q2. So Q1 is a start state. It's represented using this arrow mark. And then in that we have a final state Q2. It's with a double circled. Okay. So you can draw that two number of A's for the deterministic finite automata. One more example, how to design a deterministic finite automata transition diagram for two A's. Your automata should accept two number of A's. For example, your input, if your input having at least two A's, that is AA, otherwise three A's, AA, other four A's, A. Minimum two number of A's is there in your given question. It should accept that deterministic finite automata we are going to design. So the input is if 1A, it goes to the next state, next A, it goes to the final state. Why I have given here the final state? Because minimum two number of A's is there, exactly two A's, it goes to final state. Okay, if it is 3A's also no issues, but exactly 2A's it goes to a final state. If more than 2A's is there, it will not go to the final state. That exactly 2A's is a given question. 1A and 2A, that is the first A and second A, it goes to the final state. If third A comes, where it goes? It's not going to the final state, going to the some other state. If B comes, it's not going to the final state. If B comes, it's not going to the final state. Only if the two exactly A's comes, it's going to the final state. Okay. So in today's video, we have discussed about the 5 tuples about the deterministic finite automata. What are those? Q, sigma, del, Q naught, and F.